between 2010 to 2015, for about $5,000, you could purchase this McIntosh C48 Preamplifier. Now with inflation, that would probably be around $7,700 in 2024, going back to the 2010 price. Now, this is not really vintage, but depending on how you look at things, it could be 15 years old. So I guess in some ways, some could consider it slightly vintage. But the reason I'm doing the review is I have not seen any reviews where they measure the C48. Plus, this is something I am looking at purchasing, and I wanted to test the heck out of it, and I thought I would share the results with you. So that is kind of why I have this, and it is a DAC. It has several inputs, and we'll see all the inputs and outputs that it has, and it does have this nice backlit remote control that could control a lot of McIntosh products at the time period. And so I'm gonna go ahead and we'll pop the cover off, see what it looks like inside. I'll show you some of the controls and features in the front, and then we'll look around back and see what's going on there. And then of course there will be a plethora of data to look at, and then I'll tell you what my experience was with listening it and using it. So right now I'm going to give a little introduction into how the C48 operates a bit. Right now I've selected CD source 2 and the volume is set at 49%. Our volume control right here obviously can change it from 0% to 100%. What I'm going to do is turn it off, and I'm going to turn it back on, and you'll see it's still at 58%. However, the volume is actually muted for about 10 seconds. Watch what happens to the percentage here. It went down to 0 and then it comes up. So it's at 58%, and there's about a 10-second muting feature, which is good to save your amplifier or your ears or your speakers from inadvertently being set high and then coming on really strong. So that's kind of one feature that this guy has. Now if I hold the EQ bypass button down for a second or two, it comes up with the firmware version, and then it allows me to go through some different menus. So the first menu, I'm on the CD2 input. I have a couple of options for the CD2 input. Right now it's set at balanced 1. If I move the volume control, I can get the digital 3 input or the digital 4 input, and I can also select the RCA input, or I could just turn it off. So that's one of the features of this guy. I'm going to go put it on balanced 1. And we can do that for the different inputs. You can select, if it's aux 1, I could change it to being a couple different things: digital 3, digital 4, digital 1, RCA. I can turn it off. So you have a couple of different options depending on different inputs have limited options. So it does give you quite a flexibility in selecting different kinds of digital and analog inputs. If I wanted to, let me select another input. So we'll just say this one is the server input, which is balanced 2, and I could adjust that. This level here, I could adjust it to, if it's a real strong source that's hooked up to server 2, I could adjust that level by a couple dB. I guess you could go plus or minus 6 dB, and that would balance that input to match the level for other inputs that you may have. So that's kind of how that is done. That's another one of the features of this guy. So that's kind of how you would go through and set different things. And it also has some other menus. You can see the display brightness you can adjust, and you have different setups for different things. Your triggers, it does have a pass-through, and you could set that up. Your different trigger outputs, you can have different actions for them. The COM port is for their own McIntosh little data port they have, and then you can do your remote control codes here too. So it has a normal code and an alternate code. So that is kind of your basic setup on the C48. This obviously is the rear, and we'll start over here. This obviously is where we hook up our AC power cord. We have a RS-232 port. We have trigger inputs and outputs over here, and then we have data ports which can tie into other McIntosh gear. We have our digital inputs here, a USB input, 2 optical inputs, and 2 coaxial inputs. We have our moving coil and moving magnet phonograph inputs here, and these are their grounding lugs for each one. And you can adjust capacitance and resistance in parallel with the particular input. You also have inputs for your tuner, CD, CD2, DVD, auxiliary, and the server, which is basically another auxiliary input. And then we have record output over here, and that is a line level output that is not affected by the tone controls. You have 2 balanced inputs right here, and then we have 2 balanced outputs right here. Now, they can be switched on or off, so you could have one on or both off, and you also have unbalanced outputs right here, and those also are switched on and off. Now, I believe these are tied together, so if you want output 1 on, it's going to turn on both the balanced and unbalanced output that you selected. So that's kind of what's going on here in the rear of the C48. This is what the C48's main circuit board looks like. Obviously, our inputs are here. We have outputs here and here. Now, I believe these black rectangular devices are relays, and it kind of just gives you an idea as to what the inside looks like. Obviously, we have connections for the front panel, which would be right here. Right now, we're looking at the THD SNR plot at 1 kilohertz of the C48, and I'm using the CD1 unbalanced inputs, and I've got a 2.5 volt or 8 dBV signal going in. I've adjusted the volume control to give me about 0 dB of gain. The way that the volume control works with step sizes is that I would be about, say 0.2 of a dB less than 0 dB of gain, or if I increment it up 1%, it will be about 0.3 of a dB greater. So I went to the 0.2 dB side of that. And you can see we've got our 2.5, almost 2.5 volts coming out that we have going in. So that all makes sense. The specification is that the THD should be better than 0.002%, and we're an order of magnitude better than that. At worst case, we're at 0.00043%. So everything looks really good. The SNR's 104 dB, THD plus noise minus 102 dB. This is just looking outstanding right now. Right now, I've got an 8 dBV or 2.5 volt signal going to the CD1 unbalanced input of the C48, and we're looking at its frequency response from 20 hertz to 20 kilohertz. The specification is that it should be better than 0.5 dB, and we are well meeting that. At worst case, we're down maybe, I'll say 0.2 of a dB, and you can see that the channel balance is less than 1/10 of a dB. I should point out that I do have the equalizer bypass on. Right now we're looking at the frequency response from 20 hertz to 20 kilohertz with a 0 dBV signal applied to the CD1 unbalanced inputs. And what I wanted to do was show what happens when we turn the EQ bypass switch on and off with the tone controls all set to flat or 0. Now normally when you have a preamplifier or integrated amplifier or a receiver that might have the tone control bypass, the purpose of that is to give the flattest frequency response it can without going through the tone control. What I wanted to see is how well McIntosh handles that. So these two guys are our right channels, and with the bypass on or off, there's less than, it's 0.05 dB. I mean, we're talking 1/10 of a dB from here to here, so it's pretty darn small of a change. And with our left channels, we see maybe 1/10 of a dB when we go from the bypass off to bypass on. So there's really not a lot of change if you just wanted to use the tone controls. So McIntosh did a real good job of designing their equalizer circuitry so that it doesn't affect hardly anything. Here is a plot of the C48's crosstalk from 20 Hertz to 20 kilohertz with an 8 dBV signal going into the CD1 unbalanced input. There is not a specification that I could find, but both crosstalks are within 10 dB of each other. I guess here and here there's maybe 8 dB of difference, but it's better than 67 dB, I would say, for the left to right crosstalk, and about 77 dB for the right to left crosstalk. Right now I've got a 1 kilohertz 8 dBV signal going to the CD1 unbalanced input, and I've adjusted the volume control to get about 8 volts out. So this is about as close as I could get to 8 volts, and the gain you can see is about 10.3, 10.4 dB. The volume control is at 91%, and you can still see that our SNRs are 98 dB, we'll call it. Our THD is 0.05%, THD plus noise minus 67, we'll call it. So it's looking really pretty good. You can see that the noise over here from the harmonics has come up quite a bit. And the reason I'm running it here is that it said that it should meet its specifications at maximum of 8 volts. So the THD spec was 0.002%, so we're off on that, but we're also putting out 8 volts. Right now I have a 450 millivolt signal going into the CD1's unbalanced input, and I've set the volume control for 100%. So we're getting almost 15 dB of gain, which is the specification for this guy, and our distortion is better than 0.0002%. The specification was that it should be better than 0.002%, so we're doing really good there. And our SNRs are right at 99 dB, and we are getting about 2.5 volts output for a 450 millivolt input. And what I'm going to do is turn on the A weighting, and we'll see what happens to our SNR. So it's about 104 dB now, and the specification was that with A weighting it should have at least 100 dB of SNR. So we are there. This plot shows the system noise. In this case I've selected the CD1 unbalanced inputs and terminated those into shorts, and you are looking at just the noise of the system, which is better than minus 115 dBV. This plot shows the isolation between the tuner input and the CD1 input, and this is for the unbalanced case. And I've got an 8 dBV signal going into the tuner input, and the CD1 inputs are terminated into shorts, and this top line is what the level of the tuner input is that's going into the tuner input, the 8 dBV, and then I select the CD1 input, which, as I said, was terminated in shorts, and we get this isolation between the two, and this is really, really good. We're talking worst case isolation of maybe, I don't know, 70 dB, a little bit more than 70 dB at the worst case, and that is really good from all the different things I've measured. Here we have the C48's THD versus frequency for a couple different input signal levels, starting at 6 dBV, which would be about 2 volts in, and then going down to minus 12 dBV, which would be about 250 millivolts going in. Now the specification was that it should be better than 0.002% THD, which would be a line drawn straight across here. So you can see that probably at about maybe 200 hertz, 150 hertz, we're probably meeting that requirement. However, the worst case is better than about that would be 0.002, 0.003, 0.004, 0.005, maybe 0.006% THD. So I think that is pretty darn good across that entire frequency range. And this is for the unbalanced input, and that would be the CD1 input. And I do have the volume control set for 71%, which is about 0 dB of gain. Here is the C48's multitone response, and once again I'm using the CD1 unbalanced input, and I've got a 0 dBV signal going in, and the volume control is set for about 0 dB of gain. And this would equate to a distortion-free range of between 15 to 17 bits, which is excellent. Right now we're looking at the USB input. This would be the performance of the DAC for the C48, and I'm measuring at the unbalanced main 1 output. Now we've got our standard 0 dBV 1 kilohertz signal applied, and this is through a function called PC mirror on the QA403 analyzer. You can see that our THDs are pretty good, better than 0.03%. SNR is right around 99 dB, and the THD plus noise is a bit up there a bit at we'll say minus 72 dB at worst case. Now the volume control was adjusted so that I was getting 0 dB gain out of the C48, and that setting for the volume control for that is about 58%. So that is kind of what our performance looks like for the C48's DAC. As the C48's DAC is 10 to 14 years old, I decided I would compare it to a newer DAC, which I happen to own, which is the SMSL SU-1 DAC, and that is represented over here in this graph. And it automatically gives you 6 dB of gain or so. And so in order to compare apples to apples, so to speak, I adjusted the volume control of the C48 so I had about the same gain, so it's pretty darn close. And we've both got a 0 dBV or 1 volt RMS signal going in. And this is what we get. So we get a better SNR by 20 dB. The C48's SNR is better by 20 dB. The THD of the SMSL DAC is better by a couple orders of magnitude, but I'm not going to complain about 0.03% for the DAC. And then you can see the THD plus noise is better for the SMSL. So overall, that's kind of how it compares. So it actually, to me, looks better. I mean, you got some noise going on here, and here you got a few harmonics. I'm guessing that if you were to A/B these DACs, you probably wouldn't hear any difference in them. This plot shows the effect of adjusting some of the C48's tone controls. I just adjusted the 30 Hertz, 500 Hertz, and 10 kilohertz tone controls to their minimum and maximum gain positions or attenuation positions, and it kind of just gives you an idea to how close they are to the frequency that they're stated to be centered at, and they do a really good job actually. And you can see you're getting about 13 dB of gain or cut. Here we have the Phono 1 stage, and that's the moving magnet stage. And I should point out that I'm measuring at the record output of the C48. It's got a 1 kilohertz 4.5 millivolt signal going in. Oh, actually 4.51 millivolts going in. I do have the 200 puff loading applied to the C48. You can adjust the amount of loading on the moving magnet by, I think, about 100 puffs at a time. So I just went to 200 puff. You can see that our SNRs are pretty close to 70 dB. That's really good for a phono stage, and our THD is better than 0.002%. THD plus noise right around minus 69 dB, and the phono stage has about 40 dB of gain. Right now we're looking at the frequency response of the moving magnet phono stage from 20 Hertz to 20 kilohertz. It is better than plus or minus, we'll say 0.3 of a dB across the band. The channels are balanced to within 1/10 of a dB, and this is with 46.9 dBV or 4.5 millivolts applied to the moving magnet phono number 1 input, and that input is loaded down with 350 puff. However, I did run it through different loadings from 50 puff to 750 puff, and it didn't make any difference in the frequency response with my instrumentation. Now I should also point out that I am running it with the equalizer bypass on, and I am measuring out of the record output on the C48. Right now I've got a 0.45 millivolt signal going into the Phono 2 input of the C48, which is the moving coil input, and our THD SNR plot shows a gain of a bit over 58 dB. Our THDs are pretty good at better than 0.02%, and our SNRs aren't great, but we're looking at a moving coil cartridge and we're at about 50 dB SNRs, and the THD plus noise is around minus 50 dB. Here is the frequency response of the moving coil phono input, that's phono number 2, with a 0.45 millivolt. This minus 66.9 dBV would be 0.45 millivolts. So that's our input signal going in. It's very, very small. And you can kind of see little noise glitches here that might be as high as a tenth of a dB. The frequency response is probably maybe 0.2 of a dB on the plus side, and on the minus side maybe 0.7 of a dB. So for a very, very small signal, this guy is doing really good. And this is measured at the record output, and that is unbalanced. Here is the C48's IMD response. In this case, I'm applying a 19 kilohertz tone and a 20 kilohertz tone with their levels adjusted to give about 1 volt. And this is applied to the CD1 input, the unbalanced CD1 input, and the volume was adjusted to give a gain of about a tenth of a dB. And this is kind of just a response to the two tones. You want all these spurious responses to be as low as possible, and they're better than about 110 dB down. So that is a really good IMD response. There was not a specification for it, but it's kind of just here for reference. Here is our THD SNR plot at 1 kilohertz with an 8 dBV or a 2.5 volt RMS signal going into the balanced input, and we're measuring it out the balanced number 1 output for the C48. Now, if you compare this to the unbalanced input case with the same signal levels, and I should point out that the gains have been adjusted for either the balanced input or the unbalanced input to give 0 dB gain. When you adjust the unbalanced input, it's at about 70% volume, and with the balanced input, you're at about 58% volume, because inherently a balanced signal is going to give you another couple dB of gain. But if you compare this to where we had the unbalanced input actually has a higher SNR, maybe by 2 dB. THDs are about the same, and the THD plus noise is slightly better with the unbalanced inputs. So as far as the numbers, it performs better with the unbalanced input, surprisingly. However, if you look at the amount of noise down here, the balanced input is definitely a bit noisier, but the signals are less than 120 dB down, so it's probably why it doesn't make that much difference as far as the readings up here. Here's our THD SNR plot at 1 kilohertz, once again with an 8 dBV signal applied to the balanced input. In this case, I've adjusted the gain to about 71%, which is where it would be on the unbalanced case normally. And for that, we've got about 6 dB of gain, which is what you would expect because you have double the voltage. So you'd expect the gain to go up by about 6 dB. Now, if you compare this to the unbalanced input with the volume control set for 0 dB of gain, you will see that the SNRs are about, maybe 2 dB better for the balanced case. THDs didn't really change, but the THD plus noise, it may have got slightly better, but it's basically about the same. And it is cleaner here. You don't see as many noise spurs as you did with the unbalanced case. Right now we're looking at the frequency response from 20 hertz to 20 kilohertz of the balanced 1 input to the balanced 1 output. And in this case, you can compare it to the unbalanced input. In this case, if you compare this to the unbalanced CD1 frequency response, it's pretty much the same. It might be a little bit flatter here at the low end of the band, but the high end of the band looks almost identical. And so for the most part, there really isn't much of a change using the balanced input for frequency response anyway. What we're looking at here is the system noise level of the balanced 1 input, and it is terminated into shorts. If you compare this to the unbalanced input, you will see that the 60 hertz hum bar right here is higher for the balanced input. However, there is not as much noise at all in the balanced input compared to the unbalanced input. So that's kind of just how it looks with the balanced input. As you saw from the test data, this particular McIntosh C48 did an outstanding job of meeting its specification requirements. I think it was off a little bit in the THD versus frequency for part of the frequency range. It had a maximum THD of about 0.006%, and the specification was 0.002%. I think I can live with that. And it had some really good measurements in some areas that weren't specs, like the crosstalk or the channel-to-channel isolation. It did an outstanding job in those areas as well. In fact, I have not measured a preamp that measured as well as this particular C48. So, McIntosh just continues to amaze me, and I guess I'm starting to become a McIntosh fanboy as well as a Carver fanboy. So far, those two guys, I really like their products. Now, I should point out, I didn't mention the weight of this guy, which is around 26, 27 pounds, and it's pretty solid. Once again, it does have the remote control, which is backlit. I'll turn it on, but you probably won't see it, but it is backlit, and as I said, it controls a lot of McIntosh gear. As far as using it, it takes a little bit to get into the menu system that it has, where you could select, say, the server input and assign that to maybe the balanced 1 input. So it takes a little bit to get used to doing that, but once it's set up, you're probably not going to be changing things around for a bit. And it's pretty easy. Now, the volume control, it gives it in a percentage, and what I found is sometimes it may only give you, not only, but the increments may be 0.4 of a dB to 0.5 dB, which is generally fine, except when you're trying to do little nuanced measurements. But they're very clean steps, and it's very repeatable because it tells you you're at 71% or wherever. So that is kind of a neat feature of the unit. The display is easy to read. So the trim control, usually that's a balance control. There's just a lot of neat features. I thought the DAC worked really well as far as the USB input. Now, you saw plots where I compared it to a fairly new SMSL SU1 DAC, and this is just using the USB output, and depending on the signal level, I think the Mac did a better job with certain inputs going into the DAC at higher levels. I think it did a bit better job. For my listening tests, I connected my Wilson Watt 3 Puppy 2s to the McIntosh MC352 power amplifier, and I used both the balanced and unbalanced inputs at first. I was trying to see if I could hear a difference. The nice thing is that you can turn on output 1 or output 2. If you select output number 2, it will turn on both the balanced and unbalanced output number 2s. And likewise for output number 1, it will turn on both the balanced and unbalanced outputs for number 1. Now, that made it real easy to compare the balanced and unbalanced. As far as listening, I was curious if I could hear any difference, and then with the remote control, you can turn 1 off and turn 2 on, and that way you could have the balanced output on number 2 and the unbalanced on number 1, and switch between them within 2 seconds max. And I did that several times, and I heard no difference between the music I listened to, so that's good to know. Also, it does have a line output for recording. Now, my biggest negative, actually the only negative I think I have on this guy, is it does not have a tape monitor loop. I mean, in 2010, people aren't really thinking about tape monitor loops. Having the record output is nice, but not having a tape monitor loop for some of the signal processing devices that I have might be a problem, but I think it's one I can work around. As for the sound, I've already mentioned I didn't hear any difference between the unbalanced output versus the balanced output from the preamplifier. The overall sound was clean, it was quiet, no turn on or turn off thumps and that kind of thing. It's just a very clean, neutral sounding preamplifier. You're able to tweak the bass and treble and mid-range response with the 5-channel equalizer, and you know, it did a fairly good job overall. I would have no complaints. It's fairly easy to see the display from about 10 feet away. I don't know if I'm going to be able to see the exact percentage that the volume control is set when I'm 13 feet away, but it's a nice display, and you can adjust the brightness if you want. And I said there's so many little things you can tweak, and a big one that you can tweak is the levels. So you could set CD1 to be 2.5 dB down from CD2 if CD2 was normally had a higher signal gain coming out of it, so maybe it pushed the signal out at 500 millivolts where signal 1 might be 300 millivolts. So you could do some adjusting within the preamp and adjust for those levels so everything kind of sounds the same when you switch between them. Or if you had a tuner input and it's a certain millivolt output, you could adjust the preamplifier so that it might be the 0 dB level and then adjust your other sources. And I've never seen that on any other preamplifier. Also, you have the ability to adjust your loading for the moving coil cartridge. You can add a couple different resistors in parallel and to your cartridge, and then if you go to the moving magnet stage, you can add some different capacitance values for your cartridge matching as well. I did not listen to the Phono Input. It measured outstanding, so I'm sure it's going to sound just fine when I get that hooked up. And like always, or almost always, I didn't listen to the headphone jack because it's not something I really do, but it does have some good specifications for the headphone impedances that it will drive. So I'm sure that it would work just fine with headphones. So that's kind of my take on the C48. I don't see a lot of them for sale on, say, eBay or AudioGone. They vary in price, of course, and if you're in the market for a preamp with a DAC built in it, and speaking of the DAC, I listened to it with the optical input, and I believe I set the server 1 so that it was using the optical 1 input, and it sounded just fine. I was streaming from the WIM Mini, my own music collection, in this case that were CDs that have all been ripped to dot wave files, and listened to quite a variety of music, and it sounded just fine through the optical input. So I think the DAC is good enough for my needs. So once again, I thank you for watching this video, and hopefully you will give me thumbs up. And of course, if you have not subscribed, please do so, because that's kind of really the only way the channel will grow. If you have comments or questions, you can write them or type them, or maybe talk into a microphone and it'll transcribe it for you. However you do it, into the appropriate area on the YouTube page, and I will respond back. And until next time, have a great day or night.